Okay, and we are live. So thank you so much for everyone for joining us yet again for another workshop series for the KuCoin Labs slash SWE Summer Hackathon. As you guys know, these workshops are meant to serve as like an educational base for you guys to really help you really learn the ins and outs of SWE while you are developing your various hacks for these projects. And today, July 6th or July 5th, depending on where you are in the world. I, I am here joined by Todd. He is a software engineer at Mysten Labs, and he will be going over dynamic fields. So without any further ado, Todd, take it away.
Alrighty, yeah. Hi everyone, I'm Todd. So I work at Mysten. I've been there for about a year. I helped create dynamic fields. So if you're ever confused by them, I'm the person to be mad at. And like, hopefully by the end of today, you'll be like a little bit less mad. If you are confused, or if you're still confused after today, I guess you should be extra mad. Uh, but hopefully that's not the case. So we'll just get started here. I will sort of assume some amount of prior knowledge with move and with SWE and objects. I'm sure we have other content on that sort of stuff. At the very least, our tutorials online. So if you're confused, please check those out first. Otherwise, for dynamic fields, I'll give a kind of brief overview of just what they are, what we're talking about, and then I'll give a little bit more on how they work, and then sort of segue into a little bit more detail about objects and storage with relation to dynamic fields, and then kind of wrapping it up with some best practices. So on the overview, let's just kind of first start by looking at what's hopefully familiar, which is just a coin. So we have the object ID, and then its second field is a balance, and the balance itself is a struct, not an object, with a single U64 field. And I really just want to look at what an example object would look like for one of these. So we'd have its ID field, where it's a UID, which is an ID with the address bytes. And then inside of that, we have, or as the second field, we have the balance, which is a struct with a value. And so while these are nested structs, when we go and look at the actual serialized value for the object, we see this BCS bytes where the first segment is the UID, so the first 32 bytes. And then we have the later 8 bytes for the U64 of the balance. So there's no like struct information there, but we do have all of the bytes for all of these fields all the way down. So so all of the fields in the coin are represented in the contents. And the reason I want to talk about this is just like this is kind of what is the motivating factor for dynamic fields, is that when we have all of the fields contained in an object's contents, when we go to load an object as an input, we have to deserialize and load and read all of that information. So we're sort of like taking all of those bytes from storage and loading them into an object. So if your object is growing very large, the larger it is, we're going to charge you kind of more and more for reading those bytes. And it might get to the point where the object's so large, you'll either be tired and annoyed of kind of paying that much and it'll sort of be prohibitive for your use case, or we actually just have a hard cap on the number of bytes and you'll get stopped there. So what do we do in those cases where we don't, if we're running up to that line or we want to somehow reduce the size of our objects, we have dynamic fields as a possible out. So dynamic fields are, we call them that because the API tries to make them look like they're fields that are attached to the object, sort of related to the object, rather than being serialized in that vector of bytes. So we then access these dynamic fields with move functions during execution, instead of loading them when we load the object. And we're able to do this by making each dynamic field its own object. So we're sort of dynamically loading these objects as opposed to loading them up front, which means we can essentially make any object we want as large as we want, because we only need to load the pieces of information that we are reading or that we care about. So let's just walk through a little bit of some examples here about how these are working. Let's just take a very simple object, like a counter service. This would just be an object that has a UID, and then we want a map or a dictionary. In Move, we call them tables for reasons that we'll get into. And we'll have the key being an address and the value being a U64. So we'll have some function over this object that we're going to take and bump the value for a given user. So we're going to access the table, access the sender, and then bump and increment the count and return that to whoever called this function. So if we have a map where each of the address or each key is an address and then mapping to a U64 for the user, you might wonder, well, what happens when we start getting more and more users? Won't that object get really large? So we're going to avoid that with dynamic fields. And let's look inside of the table. You'll see that there aren't any fields listed. Well, there's two. There's just the ID, and then we also have the size. So we have the key and value for the map. And you'll see they're marked as phantom. This just means that while the type parameter is there, there's no actual value of that type contained in the struct. And so you might ask, well, then where is the data? And we're going to do it with dynamic fields, but let's first kind of remind ourselves what the bad way of doing this is. And that would be if we just took a vector and, stuffed it full of all of the values for the dynamic field. So we have, key 1, value 1. And then we just keep adding key 2, value 2, key 3, value 3. And if we kept going, this object would get larger and larger with each key value pair. And depending on how we might implement this, it gets slower and slower to access those key value pairs. So we want to separate this into separate objects so we can kind of shard and break up our object into different distinct ones. So we only have to load each key value pair that we care about during our transaction. So with dynamic fields, we take our parent object that we'll often call it, and we'll often refer to the fields also as children. You'll see that kind of terminology interplay here. And so we have our table object with its ID and a size of 0. And then when we add a dynamic field, we want to associate it with the name or the key in the map and its value. So we're going to store each entry as its own object. And where a normal object, we base its ID off of the transaction digest. So normally when we make a new object, we take the transaction digest, we hash it with whatever count we have for that object. Like each time you increment a count, that's how many objects we made, and you just get a new, kind of just incrementing a new object throughout the transaction. With dynamic fields, we take a different approach where we hash the ID of the parent, the value you have, so in this case K1, and we also hash the type. And we do this to make sure there's no overlap. So if you have, the value here is really the BCS bytes, so we want to make sure that, two different values with different types, but that happen to have the same BCS bytes don't have a collision. So here the ID is really a hash of the name of the field. And so we can add another field and we make a new object for that field and hash its key to get the object ID. And you can see here that we can keep adding key value pairs and make new objects. And the only thing we have to change about the parent table object is that size. So that means that the table's object size, the bytes, remains constant. So no matter how many fields we add, the cost of accessing and loading this table remains constant. So just to kind of briefly look at how we implement this, and this is like real snippets of source code. The table abstraction is actually really simple, a layer on top of dynamic fields. So when we want to add something to the table, all we do is use the dynamic field API of adding a new dynamic field, and then we increment the count of the table. Yeah, and so if you see here, we just access it over the UID of the object. So the dynamic field API isn't even aware of the table itself, it's just aware of the UID. And we can do a few tricks with this. There's a few different ways we can, I don't want to say abuse, but take advantage of the fact that all we need here is a UID. So one way we can do this is to add new fields to existing objects. So imagine we made some mistake, or we want to add a new functionality to an object in an upgrade. Here we have some object that has a x and y coordinate, and we have a volume which is x times y, or I guess maybe an area in this case. And here we just take x times y and return it. But maybe in the next version, we want to add a z coordinate and actually make this a volume instead of an area, sort of fixing our code. Well, we can't just add the field to the object because that would change its layout, and we call that an incompatible change. It means it would, break the current existing format for the objects that have already been created. So instead, we can use a dynamic field to add, sort of check or add for a new field z here, and then that way, the new version, the version 1 or the next version of this module can access this field without changing the struct. You'd probably need some other function to kind of, if you see here, I've checked that it exists and then borrows it. You'd probably need some other function to actually add the field in the first place. It's not like magic in that way or anything. I just want to kind of give you a flavor of the sort of patterns you might see. So also in this example, we can kind of, or with just accessing UID, you might be wondering, well, if anyone can access dynamic fields over UID, how do I protect my fields? How do I make sure that my module is the only module that can access certain fields of a certain type, or certain fields of a certain name, the ones that my module declared? And you can do this with a type wrapper. So here, instead of using a string directly as the name for the field, we've wrapped it in a type. And now the values of that type are created only inside of this module. So even though any one can use the dynamic field API that has a ampersand UID, that has the ID of the object, only this module will be able to add or remove or borrow dynamic fields over that object because it controls the creation of this wrapper type around the string. And that's what I was saying earlier about it's really important that we include the type information inside the hash of the dynamic field API or the ID, because that way we get to kind of have this sort of private field ability with dynamic fields. So just kind of wrap things up, or just kind of about the brief overview here of this section of dynamic fields. We sometimes refer to these things as sub or child objects. And so we say that we can only access them through the parent, and we can control that with two mechanisms, either controlling access to the ampersand the UID, or controlling access to the key type. And we kind of get that access control because the ID for the object is created by a hash of the parent ID plus the key or the name of the dynamic field. So you kind of have these two independent levers for controlling access. You can go look at the modules and the SWE framework for dynamic fields. You'll see that you can add or remove or borrow mutably dynamic fields if you have an ampersand UID. And the ampersand, just a read-only reference to the UID, lets you immutably borrow or just check for dynamic field existence. And we saw that in the upgrade example where we just checked for the dynamic field existing. So going a little bit more in depth about objects and storage, all of my examples so far have been sort of simple values. I'm just storing counters or U64s, and I think every one of my examples. So what about something a little bit more interesting? Imagine we have like a bank or someone that's has a table of addresses to coins, and they're managing these coins for these addresses. So now the value on our table is itself an object. So let's say we have some function to deposit here. This would really maybe be more of like creating an account. You'll get an error if there was already a entry in that table. But anyway, when we go to add like this coin with C1 to the table, we'll notice that we have this issue that now that you'll see that the coin is actually appearing in the value of the dynamic field object. So now that the coin's wrapped, if I have any of the RPC functions for SWE get object, or I'm trying to look at my coin on the Explorer, you'll see that it's been deleted or it's been wrapped and it's no longer accessible. So if this sort of functionality is important to your application, where you want to be able to easily access your objects while still using dynamic fields, there's another API, which is dynamic object fields. And we'll get to maybe some other solutions in a bit, but for right now, we have a different version of the dynamic field API that works especially over objects. So we're going to implement an object table instead of a normal table, where now we require that the value has to be a key. So that means that all of our values are objects. And here we are going to add a coin or like some object to the object table. And just like before, we're going to hash the table ID, the parent ID, and the entry into the table. And we're going to wrap the keys here. For a table, we'd actually want to wrap the keys again to make sure that we're not leaking access, or we might want to. We don't really need to because we would be restricting the access through the UID. So the only thing we need to worry about instead is just accessing through the dynamic object field. We want to make sure our object fields don't collide with our normal dynamic fields. So we have this type wrapper here. Now, instead of storing the value being the coin or the object, we're instead going to store the ID of the object. So it's almost like a simple dynamic field, but where the value is an ID to another object. And then we're going to use that ID to point to the actual object in storage. So v1, in this case, instead of being wrapped in the dynamic field, it's going to be its own object in storage. So all of the RPC calls will still work over it, the Explorer calls will still work over it, but it won't be able to be taken as an input object. You still have to access it through the dynamic field API. So back to the bank, if we used an object table in this way instead of a table, we'd ensure that all of our coins would still appear as we'd want them to and whatever various calls we'd have. So I've kind of presented these two alternative views on, dynamic fields. I think it's like you might be a little confused now about like, okay, there's all these like different APIs. You've seen table. I'm going to show you bag in a bit. What are some of the best practices? How do I know which API to use? When? What am I supposed to be doing? Just to kind of summarize, dynamic fields are really great for when your objects are going to be too expensive. So if you're worried about loading too much data all up front, you can instead just lazily load your individual fields and only access what you need at each time. Keep in mind though that there is still a cost to loading those individual objects. So I wouldn't split up all of your fields of your struct or your object into dynamic fields. You wouldn't want to do that because then it'd be really expensive to access even basic fields. But when your object starts to get large, or the contents, or you think that it might grow by a very large amount, say you're indexing based on like an address, where that could be extremely large, millions and millions of entries. This is when you want to go reach for dynamic fields. But you can even reach for it, for smaller examples, if you have like 10, even 10 entries, if those individual entries point to themselves very large structs. And you're only going to access maybe one of them in each transaction. Dynamic fields might still be a good use case for you. Additionally, as we saw in that one example, you can kind of add fields to them, or to objects, to kind of let you get new functionality during upgrades. So you can kind of add in new behavior over time without having to worry about breaking your old behavior. We kind of hope of adding some other features, making, this isn't like the end of, extending objects and upgrades, but for right now, this is it's a pretty good solution. So for dynamic object fields, I mentioned the RPC layer, and this is really kind of like, it's kind of a power user thing. You have, most of the time, dynamic fields are probably going to be just fine for you. But if your target object or your target value is itself an object, dynamic object fields will let you let the target object remain in storage. So this means that if you're trying to index them or you're accessing them through API calls, they're still going to be there even when they're wrapped. And we have, some object variants of bag, which we'll see in a second, or in table, which is our map-like API. We have object variants of those to access that basically are exactly the same code, except they operate over the dynamic object field API instead. So you might be kind of wondering, why do we do all this? Of like, why couldn't we just like do something else? And we have thought about other things. We just don't have it right now. And that's namely, if there was some sort of index that let the RPC calls in the Explorer work over dynamic fields, that we could kind of deprecate dynamic object fields. Oh no, sorry. Let's have some technical difficulties here. All right. Sorry, just issued the Bluetooth. It seems to be resolved now. So yeah, we might deprecate them at some point. Don't worry about it. If you eventually, all I just wanted to raise this is that if we get this index, you might start seeing like a lint warning or something when using dynamic object fields. But for right now, they're a decent enough solution if you really need that behavior. Otherwise, you might want to just reach for dynamic fields. So kind of continuing on the theme of best practices, dynamic fields are really great and they'll let you do lots of things, but there are some behaviors you need to be aware of and watch out for. And why we'd kind of probably push you into using or suggesting bag or table as a sort of default behavior. So let's look at what could happen, and you can kind of strand a dynamic field. So let's say you have this object, very simple, and you take the object and you're going to add some dynamic field, hello, 0, and then you're going to immediately unpack the object, deconstruct it, and then delete it. Now, if you recall, I said that you can only access dynamic fields through the parent, or the actual root object. And then, so what happens here? Well, we have now stranded this dynamic field. It's as if you can kind of conceptually think about it as all the dynamic fields have been transferred to some unretrievable address. This parent object's deleted. These are now irretrievable. So this is not good. So how do we prevent this? And we prevent it, by having APIs that would stop you from doing this behavior. So instead of adding dynamic fields to the UID directly, you can add it to a bag. Now we saw before table, which was this like a homogeneous key value map like data structure. And this is the heterogeneous one of bag, which is really just any sort of key value pair you want, any type combination, you can add it to a bag. So let's try to do the same thing with a bag. We'd add the dynamic field we want. So instead of being attached to the object UID, it would be attached to the bag. And then if we try to unpack the object, destroy the bag, well, we get a runtime exception. So the destroy empty would abort when we try to destroy the bag. So bag kind of has a built-in protection to it that it won't let you delete it unless you have cleaned up all its fields. So if you want to unpack your object, you're going to have to take the bag, transfer it somewhere else, and so that way your fields will still be accessible. I'd kind of say, when in doubt, use table, use bag. We have a few other ones like tablevec and linked table. Those are good too. But bags can only be deleted when they're empty. Tables also can only be deleted when they're empty. But if your values have the drop ability, then you can also drop the table if you'd like. But there's an explicit API for that. There's no accidental dropping. And the way I like to kind of mentally think about this is that dynamic fields are sort of the direct pointer manipulation APIs. These are the sort of core mechanisms of the language that let you implement data structures. They let you kind of allocate memory. And that, much like in other languages with these sort of memory allocation tools, you typically don't do that directly yourself. You instead use the standard library, collection APIs that build up nice, safe behavior and encapsulate that. And then you reach for the power, the really core APIs when you need to. So there's a few other data structures that I just kind of mentioned. We have bag, which is the heterogeneous collection, the map-like collection of table, and then we have tablevec, which is a little weird name, but it's really just a vector, except it's implemented with dynamic fields. And then we have linked table, which is a sort of iterable table. Um, and this way you can kind of ask for any field, you can ask for its previous or next value. So it's kind of like a doubly linked list inside of a table. So while we can implement data structures with this, keep in mind that there's not everything is going to work like you might expect from, well, I don't know what you're going to expect. Some languages work this way and some don't. If you have two tables and you add identical key value pairs to them and you try to check for equality, this example would abort. So you say like table one, table two, same values, same contents, and you go to check for equality, you'll get back that they aren't equal. And the reason is if you remember the declaration of the table, all you have is the size and the UID. And so while their contents are the same, their UIDs are different. In some languages, we consider this that like sort of tables are doing reference or pointer equality instead of doing value equality. I would just keep it in mind that these data structures are implemented using objects, and so you're going to get like object-like behavior here, where the equality is checking over the contents of the struct, which is just the UID. All right. So just to wrap up things up, dynamic fields. This is our sort of API in Sui Move for letting you add fields to large objects. They can also let you, add fields over time and upgrades. Each field, keep in mind, is its own object. So you don't always want to use dynamic fields. There is some cost. You have to pay for the object. But there's still so there's this kind of metric of when you want upgrades or you want really large objects, dynamic fields are actually going to save you something there. We have dynamic object field, which for the time being is a solution for wrapped objects if you want to kind of interact with them through the Explorer or through RPC. And we have APIs that exist that both build collections but also safe sort of abstractions. Table and TableVec, these are like collection-like APIs. And bag, well, you could kind of say it's a collection. I view it really more as a sort of safe wrapper around a UID that makes sure you don't strand your dynamic fields. So thanks everyone for listening. That's all I have today. We do have a few minutes if anyone has any questions. I unfortunately can't see everyone watching given our format here, but I think I can see comments coming in. So if you have anything there, you can ask them. Or if you're watching this at a later date and you have questions, please come into our Telegram group, our Discord groups, ask questions there. We'll be happy to help.
Awesome. So yeah, thank you so much, Todd, for your presentation. Yes, we do have 2 minutes left. I'm looking right now. So yeah, if you guys do have any questions, feel free to enter them now. Or as Todd said, if you are watching this on a later date, feel free to get in touch with us through like one of our many channels. Telegram and Discord are probably the easiest, but the forums also exist. But yeah, if you send out a question, like chances are we'll see it at least somewhere. Okay, well, yeah, I don't see any questions here. So yeah, I just
All
want
right.
to say thank you again, Todd, for doing this presentation, and thank you everyone for watching. So we hope that this is just one more presentation, one more, what should I say, tool in your toolbox for this upcoming hackathon. We're really looking forward to it, and yeah, see you guys in Paris, either IRL or virtually. Have a good one. Bye bye.
Take care, everyone.